In this video, we are going to use our understanding of how to simplify square roots involving exponents of variables to simplify some very cool problems. So it's a little bit of practice of it. If you haven't already watched my first video of how to simplify square roots involving variables with exponents, do that so you understand what I'm doing here. All right, let's do this. So you have 3 times the square root of a to the 5th, and I'm realizing that's pretty small. Let me write it bigger. 3 times the square root of a to the 5th. So, looking at this, if we're simplifying down the square root of a to the 5th, remember that what we do is divide the power by 2. Well, 5 divided by 2 is 2 with 1 remaining. So you're going to have 2 that go to the outside, a squared, with 1a remaining. Notice that that 3 is just chilling out there on the outside because it's already out there being multiplied. All right, here we have the square root of 18 times a to the 4th. Now, what do we do when we have a number that can be reduced as well as a variable? Well, until you get used to doing it mentally, I split it into 2 different problems. So let's handle the square root of 18 on its own. The largest perfect square that goes into 18 is 9. So we get the square root of 9 times the square root of 2. We'll handle that. And we'll do that one in a second. Times 4 divides by 2, because you're taking the square root, twice evenly. So that's just a squared with nothing remaining. Now we simplify this. Square root of 9 is 3. That's on the outside of the radical, the square root. A squared is also on the outside the square root. The square root of 2 cannot be simplified any further. There's no perfect squares in it. That's it. You go piece by piece and then smush it all together in the end with multiplication. All right, here, what do we do when we have 2 separate variables? Deal with it one variable at a time. So mentally, what I'm really doing here is I'm doing the square root of r to the 9th times the square root of f to the 18th. Okay, 9 divided by 2, well, 2 goes into 9 4 times with 1 r remaining on the interior. 2 goes into 18 9 times, so I have f to the 9th with nothing remaining. So now we multiply the 2 terms that are on the outside there. That would be f to the 9th times r to the 4th times the square root of r. Sweet. All right, we'll keep going on to number 4. Piece by piece. That's how we do this. Negative 5x is already on the outside. We'll leave it out there. So that's negative 5x, just chilling, times, and I'm going to separate this at least mentally, the square root of 60 times the square root of x cubed. Okay, so I've got minus 5x on the next step. The largest perfect square that goes into 60 is 4. So that's going to be the square root of 4 times the square root of 15 times the power is 3, so we divide that by 2. 2 goes into 3 once with 1x term remaining. And now from here, I'm going to simplify. So I've got root 4 is 2. So I've got negative 5x times 2 times the square root of 15. I'm probably doing this the long way. Some of you might abbreviate the steps here. And now I combine all that I can on the outside and inside. 2 times negative 5 is negative 10. X times x is x squared. And what's on the inside is the square root of, and when you have 2 things both on the inside of a radical, they get multiplied inside the radical, 15 times x. Go piece by piece. You'll be fine. You'll be great. All right, 2 more. Here we go. Just giving you like a wealth of practice and different kinds of problems to be exposed to. The square root of 21 times the square root of m to the 9th. Now 21 has no, by the way, that was a 9 here in case you can't see it. There are no perfect squares that go into 21 evenly, so it stays the square root of 21. 9 divided by 2, 4 times with 1 remaining. So I'm left with m to the 4th on the outside, and within the square root, I've got a 21 and 1m remaining from the division by 2. Piece by piece. If you look at it and say, whoa, that's super nasty, you've already lost. To win, just split it up into pieces, then you'll win right away. So 2m cubed is already on the outside, there's nothing left to do with it, times the square root of 45 times the square root of m to the 7th. Let's deal with each piece. Well, the square root of 45, the biggest perfect square that goes into that is 9. So I have 2m cubed times the square root of 9 times the square root of 5 times, now if I divide 7 by 2, that goes into it 3 times, m cubed, with a remainder of 1, so m. And now I multiply everything that I can once I take that square root of 9. So I'm going to do a little bit of mental math here. Follow along. The square root of 9 is 3 times the only other coefficient that's outside a radical, 2. 3 times 2 is 6. So those are done. m cubed times m cubed is m to the 6th. Remember, we add exponents when we multiply bases that are the same. And all I have left are the two things that are simplest radical form inside radicals. Root 5 times root m is the square root of 5m. Break it apart. Simplify each piece down. Multiply back the pieces together on the outside of the radical, square root, and on the inside of the square root. See you next time.